Hey, we're here for the second video for chemistry class, and I thought I would do another one of those weighted average problems for percent abundance because this one is in a format that sometimes confuses people, and so I didn't want anybody to be confused should you see a problem like this on a quiz or a test. So you can stop the video right now, and essentially you know what we're going to do, which is to calculate the average atomic mass of silicon from silicon's three isotopes. I realize I'm kind of going uphill here, but forgive me. I'll fire the guy that made the sign. Oh, wait, that's me. But anyway, bad jokes aside, you know that from the last video, if you've watched that, how to do the problem. But something that I found that sometimes confuses people is if you get the name of the isotope silicon-28 and then realize that its actual mass is a little bit different. And sometimes people get confused and they plug in 28 in addition to these other two values, which I don't understand, what the thought process is there. Or instead, they will just go ahead and use this rounded value and the percent abundance, totally eliminating this. And then, if somebody that's designed the test gives you this amount and this amount, if you use this amount, you're not going to get the correct amount of, it's not going to give you the correct value. It's not going to give you the correct amount of places to the right of the decimal. So what we'll do, though, is just basically what we did in the first video. And so we'll make these into decimals, and then we'll multiply them by their mass. And so the 92.23 goes to 28. So like that, and it's pretty simple. So it's going to be 0.9223. Remember, we're dividing by 100 times 27.97693 plus 0.0468. Got to divide that 4.68 times 100 times 28.97649. And then plus, I ran out of room, so I'm going to do it on another line. 0.0309 times 29.9737. So, we set it up that way. And so, I just always kind of tell people, if you're going to feel like you're going to be confused, just X those out. It's not going to hurt anything. And then, the other difference is we have three isotopes, but if you, set it up correctly, you could have 7 or 8 isotopes, and it wouldn't make a difference to what you're doing. So I'm just going to get my calculator here, 0.9223 times And so when I get everything together here, I get 28.085. So actually, let's do it because all of mine. So we get 4 sig figs here, 3 sig, 3 here. So we could really, supposedly we're only supposed to do 3 sig figs, but what we could do here is let's just keep it at 4. So we'll just go 28.09 AMU. That seems fair. The other thing that you want to keep in mind is that this answer is going to be larger than your smallest mass, but it can't be anything bigger than your largest mass. And a lot of times, people will write down answers, especially in a math class or a chemistry class, and they won't think about, hey, wait a minute, that answer doesn't make sense, because if it's supposed to be an average, and I'm reporting an answer of 500, if I have values that are 27, 28, and 29, how's my answer 500? So something that'll really help you, not just in chemistry class, but in any, all the rest of your classes is, before you just move on to the next problem, just do a common sense check. And does that value mesh with what I know I should have?